In order to calculate the moles for given masses, first we need to find out how many moles are in the element first. So the first question we have here states how many moles is 47.02 grams of carbon. So looking at the periodic table, we see that that there are 12.01 moles in carbon. So we would have to times that by the 47.02 grams that it gives us, which is the mass, in order to find out how many moles carbon has. So we would multiply 47.02 times 12.01, which would give us 564.71 grams per mole. So that would be the answer for question number 1. Then we have a second question stating how many moles is 83.5 grams of oxygen. Right here. Oops. So, like before, we have to find out how many moles are in one oxygen. And we find out that in one oxygen we have 16. So we would take 16 and times it by 83.5 grams, which is the mass that's given. And we would get 1,336 grams per mole. So the next question asks, how many moles is 189.01 of CO2, carbon dioxide? So like before, we will have to find out how many moles are in carbon and also oxygen. And since it's 2 oxygens, we would have to multiply the moles in oxygen times 2. So we have here the problem. So I went ahead and put 1 because we only have 1 carbon, and according to the periodic table, carbon has 12.01 right there, and then oxygen has 16. So we have 1 times 12.01 plus 2 times 16, which is for oxygen, which would equal 44.01 grams per mole. Then we have to take what we had in the problem. Which is right here. So 189.01. We have to take that up there, and so that equals 1 mole of CO2. And then we have to put the answer that we got, which was 44.01 grams of CO2, on the bottom so they can cancel each other out. And then we get an answer of 4.295 moles in CO2. The next question that we have is similar to the one that we had previously. It states, it asks how many moles is 137.1 of CO2. So for that one again, we have to find out sodium and oxygen. So in the periodic table, it tells us that sodium has 32.07 moles for 1 sodium. For 1 oxygen, 16 moles. So since there's 2 oxygens, like in the previous problem, we're going to have to multiply 16 times 2. There's 1 sulfur, so we don't have to multiply it. But I went ahead and put it right there. So we have 1 times 32.07, and then we have to add that to 2 times 16, which would give us a total of 64.07 grams per mole. And we just want to find out the grams, so we need to find out the moles in SO2. So we put what was previously stated in the question, 137.1 grams of SO2 equals 1 mole, and then in the bottom diagonally you put the answer that we got, which was 64.07 SO2 grams of SO2, and that will give us an answer of 2.139 moles in SO2. So the last question asks, how many moles is 63 grams of NH3, which is ammonia. So that's what it states right there. So like the other times, we have to find how many moles are in one nitrogen and how many moles are in 3 hydrogen, since it's NH3. So right here we have our problem. So we only have 1 of the nitrogen, and on the periodic table it states that 14.01 is the mole in 1 nitrogen plus 3 of the hydrogen, and it has a molar mass of 1.008, so that equals 17.034 grams per mole. Now we just need to find the moles. So we put what was previously asking in the question. So 63 grams of NH3 is the 1 mole is equal to the 1 mole of NH3. So, and then down there is our answer. So 17.034 grams of NH3. So we would divide those out, 63 divided by 17.034, and we would get 3.698 moles of NH3 ammonia. So next, we're going to be calculating the mass from given moles. So what is the mass in grams of 5.987 moles of sulfur is the first question right here. So we know that sulfur has a molar mass of 32.07. Okay, and so the number of moles that it gives us here is 5.987. So what we can do is just multiply 5.987, which is given, times the molar mass of sulfur, which is 32.07, and it gives us 192.003 grams. So that would be the answer for the first question. Then the second question asks, what is the mass in grams of 137.01 moles of nitrogen? So looking back at the periodic table, we see that nitrogen has a molar mass of 14.01. So we would have to multiply 14.01 times 137.01 in order to figure out how many grams are in nitrogen, or are in 137.01 moles of nitrogen. So right here we have the 137.01 that was given times 14.01, and it would be equal to 1,919.6 grams. So now for question number 3, it asks how many moles in 341.8 grams of NaCl. So first we need to figure out the molar masses of sodium and chlorine. Right here it shows us that sodium has 22.989 as a molar mass, and then chlorine has 35.453 as the molar mass. So using that, we're gonna find out the mass together. So we would add 22.89 plus 35.453 which equals 58.442 grams. And then after that, we take what was in the question, so the 341.8 grams, then divide it by the answer that we got just right now, that was the mass, which would equal 5.849 moles, which is the answer. Question number 4 asks how many moles in 191.5 grams of ammonium. So, ammonia is made out of NH3. So, we figure out that N, nitrogen, has 14.01 as a molar mass. So right here, 14.01. Then we have 3 of the hydrogen. So 3 times 1.008. Whenever you add those together, you get 42.038. So again, with what the question asked, it asked for the moles in 191.5 grams. So for that, you would have 191.2 divided by 42.038, which would give us an answer of 4.56 moles in the 191.5 grams of ammonia. The last question that we have is asks how many moles in 931.91 grams of Hg2Cl2, which is mercury chloride. So right here, that's what question number 5 asks. So with this one, we need to remember to put molar mass of mercury times 2, molar mass of chlorine times 2. And then after that, add them together to get the answer for their mass all together. So, here again, chlorine 35.453 is a molar mass. Mercury has 200.59 as a molar mass. And like I stated, 2 times 80 plus 2 times 35.453. And then I simpled that down to 160 plus 70.906, which is equal to 530.906. So, like the question stated, we need moles in 937.91 grams. So we take 937.91 divided by the answer that we got, 230.906. Then we get 4.062 as mass. Now we will be calculating moles from given moles. So the first example asks how much 2H is needed to react to 10.5 moles of O2, and how many moles of 2H2O will be produced. So here's the question. So we know that we need 2 of hydrogen, 2 of H2 plus O2, only 1 of O2, and then it'll be producing 2 H2O. So what we know is that the moles for O2 is 10.5. So now we put 10.5 moles of O2 on top. Then we put 2 moles of H2. And underneath we put 1 mole of O2 so they can cancel each other out. Since we have 2 of H2, 2 moles of H2 and 1 mole of O2. So that equals 21 moles of H2. So we figured out H2. Now we need to figure out the product. So we put 10.5 again, 10.5 moles of O2. And then on top we put 2 moles of H2O because there's the product is 2 moles 2 H2O. And then in the bottom we put again 1 mole of O2, which is equal to 21 moles of H2. I meant to put H2O. So the first one's 21 moles of H2, the second one is 21 moles of H2O. And it shows you right there how many moles each of them have. Okay. The next problem asks how many moles are needed in HCl to react to 131.1 moles of NH3, and how many moles of NH4Cl will be produced. So again, we want this to just show like what we need to find out. So we know we have 131.1 of NH3, and we need to find out HCl and NH4Cl. So we put 131.1 moles of NH3 on top. Right beside it we put 1 mole of HCl because we only need 1, and then underneath 1 mole of NH3. So both of the NH3s cancel out, and we are left with 131.1 of HCl. Then again we do the same thing, but on top, we will put 1 mole of NH4Cl, but it still equals the same thing. Okay, and then this question number 4 asks how many moles are needed in 3H2 to react to 193 moles of N2, and how many moles of 2NH3 will be produced. So this time I didn't put any of the examples of what we need, but we know we have 193 moles of N2, so we would put that first on top, and then right beside it we put 3 moles of H2 because that's what we need in order to have a reaction. And then underneath we put 1 mole of N2 since we only have 1 mole of N2. So you do that and your total will be 579 H2. Then we put the same number that we got in the beginning again, and we put 2 moles of NH3 since that's what was produced, and we get 386 NH3. Okay, and last question. So this question asks how many nitrogen is needed to react to 5.65 moles of 3F2, and how many moles of 2NF3 will be produced. So again, we don't know N2 plus 3F2, we know that is 5.65 moles. And then 2NF3, we also still don't know the moles for. So we go ahead and start making the lines. On top we put 5.65 moles of F2. There's only 1 mole of N2. And then there's 3 moles of F2. That's why I put a 3, 1, 3. So to cancel out, you would put 5.65 divided by 3, which would equal 1.88 of N2. Then 5.65 again of F2. And then right beside it, put 2 mole of NF3 and then 3 moles of F2, we would get this 3.77 moles of NF3. So lastly, we will be calculating unknown mass from given mass. So I have a problem here. It's not worded out this time, but we have that platinum was given to us that stated it was 4.6 grams, and oxygen was the excess. So I also put right on the reaction side that the molar mass of platinum is 78 and the molar mass of oxygen is 16, but since there's 2, you would multiply that by 2, which is 32. After getting the molar mass all together, you would add it, or you would add both of the molar masses together to get 110. And then so you would put that molar mass and divide it by 78, which is the molar mass of platinum. After that, you would get the total of 1.410, and then I put this right here in a square because that's the information that was given. So 4.6 grams of platinum is there. So we will multiply that by 4.6 grams, which would give us a total of 6.488 grams. Okay, so that was the first example. And now for the second example, I have 2 lead O plus O2 comes together to react and create 2 lead O2. So again, I put this time that lead and oxygen was the excess. I put that we got in the problem 31 grams. Then reacting to 2 lead O2. So for that, I multiplied the molar mass of lead, 207.2 times 2, which we got as 414. And then oxygen, 2 times 16, which is 32. And then add those two together, getting 446. So we would put 446 here. And the 414 is from the lead over here. 414. And so whenever you divide that, that would be 1.077. And then you would multiply that by the number that they gave us from oxygen. And that equaled 33.4 grams for problem number 2. So last problem that we will be looking at is 2 magnesium plus O2 reacts to make 2 magnesium O. And again, I put that they gave O as excess, and then that magnesium is 15 grams. And then in the reactant side, I put 2 times 24.302, which is the molar mass of magnesium. And you got that to be 48.61. Then O, since it doesn't have any, it's only 1 O, so the molar mass for O is 16. So I put 48.61 plus 16, which is the 64.61. So I would put the 64.61 right there. And then the molar mass of magnesium, which is 24.305. So I put those, divided them out, and I got 2.66 times 15, since it's what was given to us. And it equaled 39.85 grams.